Welcome to ScienceCover.com. Today we are going to look at energy types. We will focus on what are the 10 energy types, the law of conservation of energy, and how to draw energy flow diagrams. Let's start by answering the question, what is energy? On a warm day, a car seatbelt can become very warm if left in direct sunlight. In this situation, the sun's light is entering the car through the window, striking the seatbelt and turning into heat. This idea is very difficult to explain in physics as we start off with one thing, light, and it turns into something else, heat. So the idea of energy is used to describe this change in form. So energy is not one thing, it is a list of things, and we can change from one form into another. There are 10 energy types. The first is magnetism. This is the energy a magnetic material has due to its position in a magnetic field. Second is kinetic energy. This is the movement energy that an object possesses as it travels. Third is thermal energy or heat energy. This is the energy that the particles have in a warm object. The fourth is light. The fifth is gravitational potential energy. This is the type of energy that an object gains when you lift it higher, as due to it changing its position in a gravitational field. The sixth is chemical energy. This is energy stored inside substances like food or batteries that we can release. The seventh is sound energy. So this is the energy carried by waves as they move through the air. Eighth is electrical energy, which is the energy produced by a potential difference causing the electrons to flow. Ninth is elastic. This is the energy held within a stretched object, like a stretched piece of rubber band. And 10th is nuclear. This is the energy held within the nucleus of an atom. We can remember this by remembering most kids hate learning GCSE energy names. All the capital letters M, K, H, L, most kids hate learning, stand for one of the energy types: magnetism, kinetic, heat, light. GCSE stands for gravitational, chemical, sound and electrical. And then energy names, so we've got capital E, capital N, that's elastic, and nuclear. Now pause the video, complete task 1 and task 2 on the worksheet. Let's check our answers to task 1 and task 2. The types of energy were magnetism, kinetic, heat, light, gravitational potential, chemical, sound, electrical, elastic, and nuclear. And the way of remembering this is that most kids hate learning GCSE energy names. On task 2, we had to match the type of energy with the object associated with it. So the torch gives off light energy. The sandwich contains chemical energy. The bicycle uses kinetic energy to move. The kettle will produce heat energy. The upward escalator is gaining gravitational potential energy, and the stretched rubber band is storing elastic energy. Now let's think about how energy changes as it moves through an object. So let's look at a light bulb. To power a light bulb, we need electrical energy, and this is going to turn into light energy and also produce heat energy, which will be wasted. Now all of the electrical energy will get turned into the heat and the light, so we're not finishing with more energy than we started with, and we're not starting with more energy than we finished with. This idea is known as the conservation of energy. The law of conservation of energy states that energy cannot be created or destroyed, only changed from one form into another. What this means is that all the energy that is around today has been around since the start of time, and it will be around till the end of time. Pause the video and try task 3. The law of conservation of energy can be used in flow diagrams to show what goes into and comes out of the object. If we think about the light bulb, we said electrical energy enters the light bulb, so this goes on the left hand side. Then we use an arrow to represent a change taking place, and then we have light energy coming out, so that goes on the right hand side of the diagram. We'll also waste some thermal energy, so we can put that on a separate arrow. The hairdryer should run on electrical energy. It's going to change that into heat energy or thermal energy. It'll also produce some sound energy, and there's a fan inside the electrical hairdryer, so it's going to produce kinetic energy as well. The battery powered television remote, if it's battery powered, then it's going to run on chemical energy. It's going to change that type of energy into light and also heat, which will be wasted. Now pause the video and complete task 4. Let's check our answer to task 4. The toaster will have electrical energy entering it, which it'll turn to thermal energy and light energy. The battery torch, if it runs on batteries, it will have chemical energy entering it. And this chemical energy will create an electric current, so it'll produce electrical energy, which will then run through the bulb, producing light and heat. The mobile phone is also battery powered, so that's chemical energy, which again will produce electrical energy, and then that will be turned into light, sound and thermal. Now pause the video and complete task 5. Let's check our answers to task 5. A cat jumping down from the top of a wall to the ground. The cat on the wall is going to have gravitational potential energy. As it jumps down from the wall, it's going to lose that energy. It's going to become kinetic energy. A ball rolling up a hill is doing the opposite. We start off with kinetic energy because we have movement, and as it goes up the hill, we gain gravitational potential energy. The music speaker is going to start with electrical energy, and then this will start the cone vibrating, which will become kinetic energy, and that will create sound energy. The girl strumming the guitar, well, she has got chemical energy within her, and then she will use that to produce kinetic energy, movement energy, with which she'll strum the strings, so they will have kinetic energy as well, and that will produce sound energy.